Hi guys, and welcome to Organic Chemistry. So this is just an introduction to organic chemistry. We're going to look at organic molecules and what they are and the different families of organic molecules that we call homologous series. So this is just an introduction. Let's jump right in. So up until now, all we've had to deal with was inorganic chemistry. Now we're going to look at a totally different or new topic in chemistry, which is organic chemistry. Now, organic chemistry is the chemistry of carbon compounds in living and non-living systems. And organic molecules, which we're going to look at now, are molecules containing carbon atoms. They have other types of atoms in them as well, but they mostly contain carbon atoms. So let's take a look at carbon and carbon's Lewis structure. We looked at the Lewis structure of different elements in grade 11, and when we draw carbon's Lewis structure, we see that it has 4 valence electrons, which means that it can form 4 bonds. Now this can either be 4 bonds to different atoms, or we can have double bonds where we have one carbon double bonded to another carbon, or we can even have triple bonds where a carbon is bonded to another carbon with a triple bond. And these carbon atoms basically form the backbone of my organic molecule. So if I put a couple of these carbon atoms together, I link them, we see that it forms a chain. And these molecules, which we form with these carbon chains, these are my organic molecules that we're going to look at. So just a reminder, I drew this molecule here. Just remember, the reason I drew 2 dots here is, remember, these dots represent electrons, and for a bond to form between 2 different atoms, I need 2 shared electrons. So I just put another carbon here, and it gave its electron to this one, and you can continue on with this chain. If I want to draw the Cooper structure, because this is the Lewis structure, I can represent the bond with a stripe. Now remember, we said that these organic molecules can also consist other atoms, for example, oxygen, hydrogen, and my halogens. Now let's say, for example, I take hydrogen. Hydrogen has 1 valence electron, so I can bond this hydrogen to this carbon over here, and another one to this carbon over here, and another one to this electron over there. So I can do this all over. And when I draw the structural formula of my organic molecule, it's almost like the Cooper structure we learned in grade 11, but now we don't have to draw the dots, we draw the stripes. So the structural formula is basically like the Cooper structure. So I just draw that in there. So you can also have a oxygen double bond, or I can put a halogen there, something like that. Okay, so now we've looked at carbon and my organic molecules. Now we're going to look at groups of different organic molecules. So now we've looked at organic molecules as a whole. Now we are going to discuss different families of organic molecules. So as with any normal family, we don't look alike, or we don't look exactly the same, but we have features that are similar that makes us look alike. So my brother and I don't look exactly the same, or my sister and I, but we have the same features. Maybe we have the same nose, or the same color of eyes, something like that. So it's the same with my organic molecules. So we have families of different organic molecules. So within a family, the molecules look more or less the same, but they are still different. and each family differs from the other family due to a specific combination of atoms that are present in each different family. So we call this family a homologous series. So a homologous series is a series of compounds or molecules that has the same general formula and the same functional group. So that term functional group is important here because it's the functional group that determines the family to which my organic molecules belong. So within a homologous series, each member differs from the next member by a CH2 group. So all that means is if I have one molecule that has 2 carbons like here, for the next molecule I add one more carbon and 2 hydrogens, and one more carbon and 2 hydrogens. So it just means that the chain that we saw in the previous slide that we can form between carbon atoms, that chain gets longer. So it's important to look at the functional group because that determines the homologous series or the family to which my organic molecule will belong. So a functional group is a bond, an atom, or a group of atoms that determine the physical and chemical structure of a group of organic compounds. So it's important that you know what the functional group of each of my homologous series is. We are going to look at 9 different families of organic molecules, and we'll do that in the next slide. So here are our 9 different homologous series. So we have, first up, we have the alkanes. So the functional group of the alkanes is just as the picture illustrates. It's carbons bonded to each other, and these stripes indicate that they are either bonded to other carbons or hydrogen. And the important thing about this functional group is that it shows you alkanes only have single bonds. There are no multiple bonds like double bonds or triple bonds. So we call this alkane a hydrocarbon. The alkenes and alkynes as well are all hydrocarbons, but the alkanes we call saturated hydrocarbons. So saturated refers to compounds in which there are no multiple bonds between carbon atoms in their hydrocarbon chains. And here's just a couple of examples of different alkanes. So for example, we have propane, which is 3 carbon atoms linked together, and it's just important that you know the difference between a structural formula, a condensed structural formula, and a molecular formula, but we will do a different video on that. For now, all that's important is learning the homologous series and the functional group of that specific homologous series. We will also look at the names in a different video. So the alkenes, important here, the functional group is the fact they somewhere in your chain will be a carbon double bonded to another carbon. There has to be a carbon-carbon double bond in the chain. And the alkynes have a triple bond somewhere in the chain between 2 carbons, and these we call unsaturated, these 2 hydrocarbons, because these are compounds with more one or more multiple bonds between carbon atoms in their hydrocarbon chains. Now the haloalkanes, as the name suggests, it's like an alkane, but it also has one or more halogens in the chain. So normally we represent the halogens with an X. So it's also just single bonds, and then we have somewhere along the chain we have a halogen. Then we have the alcohols. The alcohols have a OH group somewhere in the chain. That's their functional group. The aldehydes and the ketones are very similar. Both of them have a carbon-oxygen double bond. But in the aldehydes, the carbon-oxygen double bond is always at the end of the chain. So that's why you have to put an H there. You can't put you can't just make a regular stripe like that, because that stripe indicates that there can be a hydrogen or a carbon, but it can't be another carbon, because that means my CO double bond is somewhere in the middle of the chain, but it has to be at the end. Whereas my ketones have the double bond not at the end of the chain, but somewhere in the middle of the chain. So they actually drew the functional group wrong over here. It shouldn't have a hydrogen there. It should just be a regular stripe indicating that it can be bonded to, it has to be bonded to another carbon. Or you can also do it like this, where you put a carbon there and a carbon there, as long as it's clear that you show that the carbon oxygen double bond is in the chain, so no hydrogen there. I got this out of a textbook, and as I'm making this video, I'm seeing that there is a mistake here, so apologies for that. I hope you don't have this textbook, or that your teacher actually showed you the right way. And then next up, second to last, we have our carboxylic acids. Their functional group is a CO double bond with a OH group bonded to the same carbon. So that carbon that has the double bond oxygen also has to have the hydrogen oxygen there, the OH group. And also again, that has to be at the end of the chain. And last but not least, I have my esters. My esters also have a carbon oxygen double bond in the chain, but next to the carbon that has the oxygen double bond is also another oxygen. So there's an oxygen in the middle of the chain, and then this that's bonded to the carbon that has the oxygen double bond. So these are your 9 different homologous series that we are going to look at. So this is organic chemistry. It's all about carbon and hydrocarbons and stuff like that. In the next videos, we will dive even deeper into organic chemistry. I hope this video helped you. If it did, give it a like and also subscribe to the channel to see more of our videos.